Welcome to the second video where we are going to be talking about compound interest. So here's what we have. We have a function a of t is going to equal p times 1 plus r over n raised to the nt. As a side note, this is an exponential function and it's almost in the right form. Okay, where a is our starting value, that's our p, and b is the thing with the exponent. That's this whole thing right here. Technically, this right here is our b. That's being raised to the t power, and then you multiply those exponents. So it basically is in this form. So p right here, it's going to be the principal. The principal or starting value, investment, if you will. I forgot to check which spelling of principal this is. All right, so we're just gonna scribble it out and let you pretend that you see what it is. Okay, R is gonna be the interest rate. And specifically as a decimal, not as a percent. That'll be important. All right, and it has some other fancy names here. It could also be APR, okay, annual percentage rate, also called the nominal rate. I don't see those very frequently, but the important thing is that R is a decimal number. All right, N right here is just the number of times it compounds per year. All right, so if you're investing something and it says it compounds annually, that's once per year. Annually means and it'll be 1. Semi-annually, twice a year, and it'll be 2. Quarterly, and it'll be 4. Monthly, and it'll be 12, because 12 months in a year, all right? Or for any Rent fans out there, for some reason I forgot the musical name. If it compounds hourly for some reason, or minutely, it would be 525,600 of those. All right. I don't remember the last person I've met other than myself. I have met myself who likes musicals, but there's that. All right, so let's use this. Example 4. Example 4, we're going to follow up with Janet. All right, I have to pick a name that's not in this class, otherwise it's a little strange. Anyway, Janet's investing $2,000. Oops. At a rate, an interest rate of 2.75% per year, compounded quarterly. And we're going to have some questions about this. If I can spell quarterly. Part A is going to be, how much will she have after 10 years? Right? Oh, and I didn't specify, but up here, T, that's the number of years. All right, if you want to include that, another bullet point. Oh, none of these are bullet points. They're all bullet points now. I'm shooting everything. That was supposed to be a bad pun. We're shooting it. It's like bullets. I'm bulleting it. Like with a... We're going to move on. All right, so we just have to identify everything. A of t is equal to P. P is our principal, right? It's our starting investment. We are investing, no, we aren't. It's Janet's money, all right? Let's be clear on that. Janet's investing $2,000, so that's going to be the P. All right? Next is 1. It's always a 1. Plus R. R is that interest rate as a decimal. So this is not a decimal. This is a percent. 2.75%, you move the decimal twice. All right, so it's going to be 0.0275. All right, over n, which is how many times it compounds in a year. We're compounding quarterly. That's every quarter of a year. So it could be like very commonly, right? In like businesses, quarters could be like January through March, and then April through June, and July through September, and then October through December. Right? There are 4 quarters in a year. Makes sense. Quarter, right? N is 4. All right, raised to the n, which again is still 4, same n, times t. And specifically, we want to know after 10 years. So if I were really thinking ahead, I could have plugged in 10 for t. So you get 2,000 times 1 plus 0.0275 over 4 raised to the 4 times 10, which is 40. You just type that into your calculator. You don't need to worry about simplifying this. You do not need to do this by hand. That would be insane. Okay, it's possible, but it would take a very, 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 very long time. Okay, you type that into your calculator and you're going to get an answer. Right. So, for example, over here, if I'm going into my calculator, which is Google. All right, if I'm going into my calculator and I'm typing it in, you see what I'm just typing in exactly, right? 2,000 times parentheses 1 plus 0.0275 divided by 4 raised to the 40th power. That's not a dollar amount, right? Okay, that's 2630.5848, and it probably goes on even longer than that. Maybe, probably. So let's round that to a dollar amount. We're going to round everything to 2 decimal points. All right. So that's the wrong scene. So we plugged into our calculator and we got, it went away for a second, $2,630.58. Make sure to include the dollar sign. We're not talking about euros or pounds or anything like that, or cents. All right, so in 10 years, our investment grew from $2,000 to $2,600, okay? So not great. And in fact, that's roughly very similar to inflation, right? I think inflation's around 2% every year. So if you're investing something and you're getting less than 2%, you're actually kind of losing money. But that's neither here nor there. That's not part of this video. All right, let's keep on going with the part B. All right, if it compounded monthly instead of quarterly, how much more would she make or have? So we're going to do something very similarly, but instead of n being 4, right here, n is going to be 12. It's going every month. So again, a of 10 will still be 2,000. We're still investing 2,000. We have the same interest rate, but now n is 12. Okay, so our exponent's not 40 anymore. Our exponent's 120. All right. So again, we just plug that into a calculator as well. Replace it with 12. Replace this with 120. And we should get 2632.23. All right, as a side note for how compound interest kind of works, right? If we have 2% interest every year, then at the end of the year, we have the same amount of money for the whole year. And then at the end of the year, it bumps up by 2%. Okay. But if I have 2% semi-annually, then in the middle of the year, we get part of that 2%. And then at the end of the year, we get another part of that 2%. And that's what this NT kind of says, right? If it's 2% only once, that's just 1.02 is what we get right here. But if we split it up, we get half of that, but we're going to get it twice, right? If n is 2, then it happens twice. So we're compounding more times in a single year. That's sort of what's going on there. And again, I could talk about that for a long time if we don't really have time. So this isn't our answer. How much more would she have? This is how much she would have for compounded monthly. How much more? We just have to find the difference. Okay. So just find the difference between those two numbers with a calculator. 2632.23, 2630.58. She would have $1.65 more after 10 years if it compounded monthly. So compounded monthly, you're going to make more than if it compounds quarterly because it's growing more frequently. Still the same interest rate, but it's growing on itself more. Okay. But after 10 years, a difference of $1.65 is not super big. Okay. But as it compounds more, you do make more money. Okay. So that's pretty much it. There's a couple variations in this section for solving for variables and using those formulas. That's sort of just going back to other algebra stuff. If you do have questions, I'd be more than willing to answer them. But this is essentially the section right here, compound interest using this formula. This guy right here. All right.